Today we're doing lightning talks, which is one of my favorite type of talks to come to. You get to see typically 3 to 4 different topic talks, and that's what we're going to give you today. There's 4 of us going to come up here and pretend like we know what we're talking about and give you some of our knowledge. So today I'm going to be talking about Exasol. So Exasol is a database technology. It's something that my company has been looking at, and I've been looking at a little bit myself, so I'm going to kind of tell you about it and then give you a use case and show you a little bit about it. A little bit about myself. I'm a software architect for Interworks. We do a lot of business intelligence, IT services, and data consulting. We're here in the city. We're based out of Stillwater, but we have offices all over the place. We work at companies that rhyme with Pikey and Boogle and all the big name that you might heard of. Our bread and butter is Tableau Server, so we do a lot of Tableau, not Tableau Server, but Tableau in general consulting. And so what I do is work on a team that creates tools around Tableau Server and Tableau Desktop. So without further ado, let's get this started. I will give a disclaimer. I am not a data guy. I'm a software guy. I've been writing code for 14, 15 years. So a lot of this stuff that I'm going to tell you is a little over my head. So if it doesn't make sense to you, that's cool. It doesn't make sense to me either. So what is Exasol? It's a columnar store in-memory massively parallel processing RDBMS for data warehousing and analytics solution. That means it's fast. It runs on x86 servers. It can go across hundreds or thousands of nodes, support thousands of users, highly scalable. And it supports 2008 ANSI SQL, so that means that me and my background, that fits perfectly because I'm typically a Microsoft SQL Server guy, Postgres, MySQL type stuff, so I can take those skills and work with this database. So here's the logical architecture. Basically, it runs on Linux servers. It has its own management software and also software to control the storage and cluster. Key capabilities. So it's in-memory technology. That means it's really fast, right? It can process everything in memory. It doesn't have to go to disk. Columnar storage reduces the number of I/O operations. Massively parallel processing, I really like that term. It means it's fast. High user concurrency, supports thousands of users. Scalability, it scales linear, so you can add as many nodes as you got money to do so. A tuning-free database, so this means that it self-tunes. It has some intelligence behind it that knows how to optimize indexes and all that type of stuff that kind of frees the DBA or anybody that's managing the database. They don't have to necessarily worry about that. It has industry standard interfaces, advanced analytics, and plays well with big data. Has integrations with Hadoop and others. This is how they kind of see themselves in the marketplace. They fit well in the mid-range data volume, but high performance. So when you're looking at, high gigabyte, mid terabytes, that's where their bread and butter is as well. Any questions so far? Yes, sir.
You said that it plays well with Hadoop. What type of integrations does it have?
That's a good question. I'll get back with you on that one. I was reading the marketing material. Sorry. All right. So how does it compare to others? So this guy, Mark, not this Mark, another Mark, did this really cool study where he took a bunch of data from New York taxi rides, Uber rides, and London cab companies, I want to say, for several years. And basically he got a data set that has over 1 billion records of trips that were made. And so he did some comparative studies for us on various database technologies. And I'll kind of give him a shout out on his blog. So this is the mark that I'm talking about here. And I've got this in my references at the bottom, so whenever I publish these slides, you can take a look at it. But basically, he shows all of his results down here, and then he also shows you how, if you want to create this data set, how you could come and do it yourself as well. So it's really neat. It's a really cool data set. And for me, it was really awesome because it had step-by-step instructions on how to actually import the data. So here's what the results look like. You've got some like really high tier, very expensive database technologies at the top. And then you have this Redshift one that I kind of want to point out. I don't know if my mouse isn't showing, but it's around where it says the 1.56, 1.25, 2.25, 2.97. It's a 6-node DS2 extra large cluster. From what I understand, that's about $570,000 a year to run. And so what we did at Interworks is we're actually partnering with Exasol, and so all we had to do was buy hardware. And so we bought this Dell server right here, right, and this is the specs for it. It cost us about $15,000. Now, to run this with licensing cost, it would be probably around 50 would be the high yearly cost. So really not comparing apples to apples, right? 500,000 to 50,000. And this is what speeds we were able to obtain in our environment. And so it's pretty close to the Redshift. You know, it's for $450,000 less. I think I'll take these times over that, right? It's okay. Oh, is it really that fast, right? So let's see. Come on. So let's see which one. It's really hard. It's really hard trying to do this on the other screen. But so this is using the same 4 queries that we saw in that other study that Mark did. I added one just to get the row count so you can actually see that I'm not cheating you. I'm looking at the other screen. Okay, so you can see at the bottom, that's the results. I can't really see them right here, but this first one should be the record count. So you can see there should be 1 billion records in our data set that we're going against. And then here's the time. So we have 2.5 seconds. I can't see, is that 1.4, 2.7, 2.9 maybe? So that's pretty fast, right? Pretty fast. And that's using that server that I just mentioned with those specs. So that's all fine and dandy if you got a lot of money. But there's a free version, right? Right. So here's how they price it out, or not how they price it out, but here's the SKUs that they have. They have a free small business edition, and that's the one that interests me. So this one allows you to, it doesn't matter how much data you have, how much you use it, the only limitation is the amount of memory you can use. So as long as you are under 200 gigs of memory, it's free. And then they also offer community support on that free edition. So why does Matt care about this? Okay, so I mentioned that we write tools, or I think I mentioned that we write tools for Tableau. And so one of our latest tools is a monitoring system. So this system ingests a whole bunch of logs, monitors a system's processes, and gathers all this data and throws it into a database. And then we try to make it where a user can come in a user-friendly way and figure out what problems are going on, right? So kind of like a New Relic-ish type thing for Tableau. Show you real fast, just because I'm awfully proud. So this is kind of what it looks like, and you can see it shows metrics that you would expect to see on a server monitoring tool. So this monitors a Tableau server that has multiple nodes. You can get all the performance data, the Tableau processes. So these are the different processes that Tableau spins off. The background tasks, slowest views. So this really just helps you figure out if your server's performing poorly, why it's performing poorly, and also if you have slow views. So Tableau produces data visualizations, and a lot of times people will just kind of drag and drop stuff, and they can have really slow views. This will help you dive in and figure out what queries, what views, what's causing it to slow down. So enough of the plug. So we store a lot of data. We have the option of storing in Postgres or SQL Server. After a few million records, our application starts to go really slow, right, as you can imagine, right? We're querying across multiple tables, trying to figure out correlations between different data sets, and it slows down. So what did we do for a temporary solution? We optimized some of our poor queries, right? So we identified some places that we weren't doing very performant queries. We made some modifications there, and then we do what a lot of people do, and we limited the amount of data, right? So we're like, okay, now by default, you can only have 2 weeks worth of data, and that amazingly increased performance, right? So that's a temporary solution. What's our long-term solution? We're looking at a separate archival database, and that's why we're looking at Exasol, right? So another alternative that we looked at was Greenplum, but we like Exasol a little bit better. So I had to create this demo so I could show you the difference between a Postgres example and Exasol example. And what I did is I took a subset of the data and just got 100 million rows and used, I'll show you the server specs in just 1 second. But as I was creating the demo, I did some stuff like this and this and this. And I'm a Windows guy, so it made me feel like this. So yeah, it was pretty neat. I got to learn a lot working in Linux and stuff like that. I typically work, like I said, in Windows, so it was a fun experiment for me. And so this is what the demo actually is. It's a smaller subset. It's 100 million records, and I'm using M4 X large. So if you guys know what that is in AWS, right, that's basically a 4-core, 16 gig of memory server, very low cost. And so I meant to start this at the beginning because it takes too long to actually run. But trust me, I'll run it and I'll show it to you guys later. But running on Postgres, each one of these queries takes over 6 to 7 minutes, and the final one takes 10 minutes. Ooh. I think it's easier for me to look over this way, if I can find my mouse. All right, so I'll run this first time. It should be fairly fast. I think it said like 2 seconds, 4 seconds, blah, blah, blah type thing. So it's really fast. And what's really cool about this in-memory database is if you allow it to cache, got to run it twice, sorry. It's got to cache it. It's in milliseconds, right? So it's less than a second. So pretty cool database, right? That's all I got. Thanks.